Hi, my name is Daniel Jacobson, and I'm a program manager on Visual Studio. Welcome back. It's obvious that you found our first couple of videos in this series helpful, or you probably still wouldn't be watching. I think this video is one of the most important ones, though, so I'm glad you're here. What I'm going to talk to you about today is some more advanced topics around .NET Native. Specifically, I'm going to show you how you can debug issues that you may encounter while using .NET Native. I'm going to talk to you a little bit more about some details about the technology and some issues you may encounter as a result. And then I'm going to tell you kind of who to reach out to if you're really struggling and you can't figure out how to work around an issue because of .NET Native. The final thing that I'm going to show you is what you can do to kind of optimize the performance of your continuous integration build servers. As I mentioned in my previous video, when you upload a package to the store, you're actually uploading the intermediate language package. So why do we have to do the .NET Native compilation? But we'll get there. To start with, let's start with a demo project. So first, let's start with a really simple universal Windows platform application that I created. I'm in debug mode, my traditional development environment. I'm running x86, and I'm just going to run it on my local machine to start with. I kind of want to show you what this application does, and then I'm going to switch over to release mode to test my application. Let's say I've been developing this for about 4 hours, and I want to make sure that my application still performs like I would expect it to. So here we go. My application is finished deploying, and I'm going to hit a breakpoint. I can also see I get some good debugging information. My border thickness looks good. Cool. So as you can see, it's a simple black square with a simple red border. Now let's go ahead and switch over to release mode and see what behavior I get. So that's done, and let's run. All right, here we go. Well, that's interesting. I lost my top, my right, and my bottom border. So one thing I want to stress here is you can definitely see the importance of running release mode. You may get some behavioral differences. While they're rare, they do happen. The other thing that's interesting is I have no debugging information. So this is going to be a really hard problem for me to solve right now. And that's because I'm running in release mode. When you run release mode, the code is optimized and any sort of kind of debugging metadata is stripped from your package to optimize it for your customer. So how do I debug this? Well, I'm going to show you. So I'm going to right-click, go on Properties, and under the Build tab, I'm going to change my configuration to debug. It's already active, that's good. And I'm going to click Compile with .NET Native Toolchain. So essentially what that's doing is it's taking my existing debug configuration, which is optimized for debugging, and the only thing that it's adding is the .NET Native Toolchain. So I'm going to switch over to debug, make sure I save, make sure my breakpoint is still in the place that I want it to be, good, and run again. And now let's see what happens. Okay, so my application has finished deploying, and now I can see I actually have some useful debugging information. So let's take a look at my border T, my thickness T, sorry. And I can see my left property has a thickness of 8, and my right property has a thickness of 0. And if I look at top and bottom, I can also see that those are both 0. So, great. That's way more useful than what I had before, but that's still kind of an interesting issue. As it turns out, this was a bug in the .NET Native compiler. It was stripping out too much information. And the way to fix it is to just remove the static keyword or to actually explicitly declare the thickness of all 4 borders. So if I were to run this again, I would have the full border. But what I want to emphasize here is that .NET Native is still a new evolving technology. It's imperfect, but it's getting better with every release. This bug was already fixed in Visual Studio 2015 Update 1. So if you continue to use the latest tools, you will get a much more consistent and stable development environment and much fewer issues with .NET Native. The next thing I want to talk about is a couple of other issues that you may encounter while running your application in release mode with .NET Native. But before I talk about these, I want to explain kind of where they come from and what the technology is doing. So one of the big challenges with the .NET Native technology is kind of figuring out exactly where to draw the line when it's optimizing your package. So one of the great features is your application runs faster, performance benefits, etc. But if we were to include all of the type information that's necessary for a managed package to do everything possible, the package is going to be huge. And what I mean specifically is reflection and serialization. One common misconception with .NET Native is that you no longer have serialization or reflection capabilities that you're used to in .NET, but that's not true. In almost all cases, serialization and reflection will still work, and they'll work great. And .NET Native is smart enough to figure out exactly what type information needs to be statically compiled into your application package to actually complete those functions. It's not perfect. In rare cases, or in rare occurrences, sometimes it'll strip out too much type information such that you'll hit one of these exceptions: a missing metadata exception, a missing runtime artifact exception, or a missing interrupt data exception. One of the things that I really wanted to do for this presentation and previous presentations was actually find a screenshot of one of these exceptions in the wild. And that's really tough to do. It's getting harder and harder with every upgrade to .NET Native. So it's, while I call this slide common issues, it's really just a relative term in the sense that it's more common than the issues we'll see on the next slide. But to fix these, you can actually do some cool manipulations with runtime directives. And what that means is I can specify exactly what type information I want to be preserved or included or excluded from my application package. Now, this is an expert level topic and would take much longer of a video, but this is just to get your feet wet. There's a ton of great information on the .NET Native blog in this .NET Native deep dive post. It talks all about runtime directives and how you can include or exclude extra information. The next thing I wanted to talk about is some not so common issues. So these are extremely rare at this point. Sometimes the most advanced applications that have tons and tons of third-party references and library references hit compiler errors. If you see something like this, don't panic. We're here to help. We get tons of traffic on this alias all the time, and we're excited to help our customers. So please, if you encounter any sort of internal compiler error or cannot generate serialization code error, go ahead and email us at netnativehelp.com, or sorry, netnativehelp@microsoft.com. The last thing I want to talk about is optimizing your continuous integration build service or servers. So when I'm a really, really quick agile shop or a Windows shop, and I want to produce an Apex upload every day to upload to the store to a beta group of people or distribute it internally or however I want to publish my package. Well, in that case, I may not want to always use .NET Native when I'm building my Apex upload package. After all, as you saw in the first video, or I guess the second video, the first video with me, the Apex upload package only contains intermediate language binaries. You're not actually uploading the native package to the store. So what I can do is, in my build definition, I can pass this build flag to MS-build. The property is UWP Apex package build mode equals CI, CI for continuous integration. One caveat is that I must also be building a release package. The other requirement is that I'm using Visual Studio 2015 Update 1 on my build server. Since this flag is a new feature in Visual Studio 2015 Update 1, it's only available there. Some of the performance wins we've seen with this reported to us are from 22 minutes down to 4 minutes. So if build credits are kind of important to you, or if you want to build these packages as quickly as possible, you can use this flag. The one thing I will say is please be careful with this flag. Make sure you are doing your diligence testing your .NET Native packages. That is ultimately what your customers are going to get on their devices. And if you don't test and you just use this flag, you may be shipping a product that crashes as soon as you start it up, or you may even not be able to upload to the store because it fails compilation. So this is great for build servers, not great for local testing. With that said, that's all I wanted to talk about with you today. Again, if you have any comments, questions, concerns, or issues with .NET Native, please message us at netnativehelp@microsoft.com. Thank you.